all of us have seen Slinkies from time to time. This one happens to be a plastic colored one. Most of us remember the metal ones that are that you let climb down the stairs. But there's some scientific information involved in this as well. These are helical spring toys, which again could be a math lesson for that matter. And it's quite easy to talk about the formula for dimensions and variables and so forth in terms of a Slinky and the equilibrium that's involved. And there's some information in the notebook that talks about those formulas and the terms that go with those. But most of us remember the Slinky going down the steps a little at a time. Well, what in the world would cause it to do that? It has to do with the pre-compressed helix spring. Now, this was this was developed by Richard James in the early 1940s, and he hoped it was going to help be a balance in ships because at the time he worked for the Navy. Didn't work out that well, but his wife said, I think kids would like to play with this, so they developed it as a toy. So it has to do with things being stationary and going with zero velocity. So what happens is you won't be able to see as well unless you just do it yourself where you can actually see. But what we're going to do is I'm going to drop this in a minute. And what's going to happen is that the bottom part of it is not going to drop until the top gets to it, which to me is a really unusual phenomenon. When you think about dropping something, normally the bottom is going to drop and then everything else is going to drop at the same time. But this has to do with Hooke's law, H-O-O-K-E, has to do with Hooke's law of gravitation. So sort of an interesting gravitational thing. So if you'll watch, maybe you can see, let's see if I can stop the end of it a little bit, but notice that the bottom is not going to drop until after the top has already started to drop. So when the top catches up with the bottom, then the bottom will drop. Now obviously this is going to happen very quickly because we don't have time-lapse video, but if you do it in front of the students, they will understand what you're talking about. So an example of Hooke's law, let's see how it looks. One more time. So the top's I'm going to let the top go. The bottom is not going to start dropping immediately like the top does. It has to do with Hooke's law. Slinky fun.